Hello guys, today we are going to solve the integration of exponential raised power negative x squared dx. So this sum is a non-elementary sum. So all in another term, it is indefinite integral. This means that you cannot solve it through direct integration as we used to other sums. So in this one we are going to deploy a method known as Gaussian method. This method gives us a graph which looks like this. So in this case we are having two similar triangles. So if we take this one at square, so we'll be having something like this dx. So this one will be squared. This one will be squared. So this automatically will give us two integrals. That is, one will be from negative infinity to infinity exponential of negative x squared dx, and this will be multiplied with integral of negative infinity to infinity of the same, but now we are going to have y squared dy. This, now we are having these two. We have opened the squared, so we are having this first term and the second term. So this one, by using this one, we are going to get, by bringing together this one, we are going to get exponential of this negative infinity to infinity exponential negative. Now this is negative x squared plus y squared dx. Up to there. Now this one is negative x squared and this is negative y squared. So we'll be having something like this: negative x squared minus, but here because it is multiplication, so we'll be having positive plus negative y squared. So this one will give us negative. When we get out the negative, so we'll be having x squared plus y squared. Now here we come. Here we are having something. We know that x squared plus y squared is equal to r squared. That's right. So we are going to replace our x squared plus y squared with r squared. So our equation will be integral of exponential from negative infinity to infinity negative r squared. Now because we have impressed r squared, we are going to have actually here we had dx dy, because this one dx and dy. So here dx dy. That's all what we have. But now when you go to polar by Cartesian method, you're going to have something like a circle, so this will be in a Cartesian plane. So we are going to have this one 80 degree, this 0, it can be 360 degree. So this one up to here, from here up to, we go round up to here, that's 2 pi. So by so doing, we are going to take a portion and assume that our elementary function will, our field of study will be here. So we'll be having something like something of this sort. So this one area is a dA. This one is a dA. Then here we'll be having a d theta. Then here now is where you're going to have something like, because we know that this one from here up to here, let me draw this at a bigger angle. So we're going to have, let me drawing, we're going to have something like this. So this is d theta, d theta. Now I was drawing this figure here, then you're going to have a shaded part there. That's where you're having, like, let's say, like, if we were looking at a small portion here which is in form of a triangle, we're going to have this dx and dy. So the area dA will be equals to dx dy. Same thing, we're going to come here, from here up to here we are going to have, this is r, so we are going to have r d theta as usual, but the distance from here up to here will be something, a small r, so it's dr. So after that we're going to have r d theta times dr will be equals to our dA. So this is our dA. Then from our previous sum here, we are now going to second integral. Oh, sorry, here we had a negative integral to integral also here. I'm sorry for that. So after that we're going to have our two integrals. Now here from 0 to 2 pi, because we have started it at an arc. So if this is just a portion of a circle, so what about from the whole if you go around from the whole circle? So we are going to have our exponential r squared r dr d theta. So here it is 0 to, but dr, now we are going to look at 2 pi or integral of 0 d theta exponential negative r squared r dr. Then we are going to having this one from 0, integrating from 0 to d theta. This one gives us automatic 2 pi, because we are coming from here up around up to this point again. So that is 2 pi, the distance is 2 pi. So this will be, this one will result to 2 pi. Then we will be left with negative infinity to infinity. We put our limits, yeah, negative infinity to infinity exponential negative r squared r dr. That's okay. So we are going to assume that negative r squared is equals to s. Negative r squared is equals to s. So our ds will be equals to negative 2r dr. Then the r here is a Jacobian factor that disappears since it is a Jacobian, which express because of transformation to polar coordinate. Now we're going to have our sort as 2 pi negative theta, negative infinity to infinity. Now we are not going to put negative s, we are going to put s, which is the same as r squared. If you put s, we are going to say ds, where ds we know is this one. When it comes to this one, then we are going to be left with 2 pi into bracket exponential 0 to exponential infinity. But remember, here we added 2, so the 2 over 2, this 2 goes, so we are going to be left with exponential of this 1, this 1, and this one seems to be 0, so this one will be pi. So our solution was for negative infinity e negative x squared dx into bracket squared is equal to pi. So back to our question, it was how to solve exponential from negative infinity to infinity. So our solution will be exponential negative infinity to infinity exponential this by negative 2x squared dx equals to square root of pi, and that's our answer for this equation. So I'd like to say thank you for listening. Keep in touch. I'll be dropping another video soon, and may God bless you. Please like and subscribe.